Thank you, Stefan. We're moving ahead. I'd like to invite Alex Adamu, Chief Scientist, VESSELSVALUE, to the stage, please. And Alex will give a presentation entitled, Do Energy Efficiency Indices Predict CO2 Emissions? Alex, please.
Thanks. Thank you, Kevin, and everyone at Marine Money, and hello, everybody. Okay. Good, that works. Okay, yeah, so my name's Alex Adamu. I'm the Chief Scientist at VESSELSVALUE, and I'll be speaking this afternoon about the question, do energy efficiency indices predict CO2 emissions? In fact, I will not confine my talk to that question only. I've got a few other questions I'd like to address. Firstly, an introduction to VESSELSVALUE. Many of you will already be familiar with us, but for those who aren't, we're a data and analytics company launched in 2011. We have 9 offices worldwide, a lot of staff, even more clients. Oh, sure, yeah. Yeah, so mainly focusing on maritime data and analytics, but also moving into aviation, so general transportation assets. Our core product is asset valuations, but we're now moving into other products like forecasting, trade data, green, and so on. So the agenda for my talk is I will introduce energy efficiency indices. Actually, I will be able to whip through that quite quickly because our friends at IDWELL have done a very good job just now of doing that. And then once I've done that, I want to use some VESSELSVALUE data and analysis to answer a few questions. So the first being, how well do existing vessels comply with technical requirements? Do technical requirements, in other words, EEXI and EEDI, predict actual CO2 emissions produced by vessels? And how much of actual CO2 emissions can we potentially save through operational efficiency? And then I will conclude with some final thoughts. So, energy efficiency indices. The background to all of this is, as I'm sure you know, the International Maritime Organization goals, which are to reduce CO2 per unit transportation work by 40% by 2030 and 70% by 2050, and then total greenhouse gas emissions by 50% by 2050. But as we've already heard this morning, it may be that the industry itself defines even more ambitious goals than that. Those reductions are relative to 2008 levels, and as Stefan mentioned, the IMO has established 2 regulatory indices for live existing vessels, the EEXI and the CII, which come into force in 2023. So the concept behind both of these metrics is actually the same. It's the efficiency ratio, which is the mass of CO2 emitted divided by the cargo capacity of the vessel times the distance moved. And so the units of that are grams CO2 per ton nautical mile. And I think there's a few points that are worth noting about this sort of metric. Firstly, as it says on the screen, strictly speaking, this is actually a measure of carbon inefficiency and not energy efficiency. So when this number is high, it means we're burning a lot of carbon to do a piece of transportation work. I think another point to bear in mind is that this is not a measure of CO2 emissions. We can actually emit a huge amount of CO2, but if we're moving a lot of cargo, very long distances, we can have a low efficiency ratio. And finally, this sort of metric says nothing about the carbon intensity of the cargoes that we are moving. And obviously that is an important question if we're looking at the overall global picture. So very briefly, on the energy efficiency existing index, this is a modeled efficiency ratio which is based on a vessel's design and equipment. So it's a purely technical index that is agnostic to a vessel's operations. And it's very similar, in fact, it's based on the Energy Efficiency Design Index, EEDI, which has been enforced since 2013 for new build vessels. I've reproduced the formula there. We don't need to worry too much about it. The point really is just to say that it is a model. And compliance is if the attained EEXI is less than the required EEXI as specified by the IMO. So moving on to the carbon intensity indicator, this is an actual efficiency ratio, which is based on the fuel consumed and the transportation work done. It's computed annually from vessel data that's submitted to the IMO's data collection system, or DCS. And because it measures real emissions, it will depend on both a vessel's design and also on its operations. And compliance is being enforced by banding CII from A, which is the least emitting, to E, which is the most emitting, and then enforcing incentives and penalties. So just to recap, we've got the EEXI and EEDI, which are models, and then we have the CII, which is reality, if you like. So the first question I wanted to address was technical compliance of the global fleet. So this is a screenshot of our Vessels Values energy efficiency tab, and this is for the global VLCC fleet. So what we're plotting on here is what we call the compliance gap, which is the attained EEXI minus the required EEXI. The compliance line is shown horizontally in red, and then vessels which are below this line are compliant, and vessels which are above the line are non-compliant. Now, I should be clear, this is the global VLCC fleet. This is estimated data, so this is not based on the EEXI technical files of the vessels. This is based on our estimates using what we know about the vessel specifications. And what we can see here is a fairly clear trend, which is that the newer vessels tend to be compliant, and as vessels get older, compliance is lost. We've done an analysis of EEXI compliance for the 4 major sectors. That's tankers, bulkers, containers, and gas ships. Now, this is for larger vessels. This is for vessels essentially over 20,000 deadweight. And what we find, I think, is quite interesting and is consistent with some of the reports that we've seen in the media. There isn't a single one of these 4 major sectors that has the majority of its larger vessels in compliance. And particularly worrying, I think, is the bulker sector, where we're estimating almost 90% of vessels failing to comply at the moment. So more work needs to be done to meet this metric. And what sort of work might that be? Well, for marginally non-compliant vessels, owners may look at retrofitting of energy-saving devices, and I think we're going to hear about that in the next talk from Newport Shipping. If the compliance gap is greater, then owners may need to look at engine power limitation, in other words, derating their engines. This clearly will have an impact on the maximum steaming speed of the vessel, so there may be commercial implications for doing that. And then for the vessels which are grossly non-compliant, it may be that, the engine power limitation required to return to compliance will be too great, and these vessels may be candidates for scrapping, which we've mentioned, which we've heard about earlier today. So that is compliance with the technical indices. Now, are the technical indices useful? Well, they would be if they predict actual CO2 emissions. So that's the next question I want to look at. As I said, EEXI is a model of how fuel consumption depends on vessel design and equipment. How well does it predict CII, which is based on actual CO2 emissions? So to answer this question, we had to get some data. Now, the IMO DCS data are not public. As an aside, in my opinion, I don't think that's good enough. I think they should be, but they're not. But fortunately, the European Union's Monitoring, Reporting and Verification, or EU-MRV data, are public, and these give fuel and distance data for all journeys involving a member state port, And we took the data from 2018 to 2020. And what we did is we plotted on the horizontal axis here the technical efficiency ratio, in other words, the EEXI or EEDI of the vessel, and then on the vertical axis, the actual efficiency ratio, in other words, the CII. And for the technical measure to be a good predictor of the actual measure, we want to see a straight line with a gradient of 1 here. And in fact, for tankers, this is pretty good. We get a gradient of, on a least squares best fit of 1.04, and for bulkers, also a gradient close to 1. But you can see that although the trend is pretty good, there is a lot of variation in the data. So looking at predictive accuracy, we measure the percentage predictive error, which is the actual CII minus the model EEXI, and we get a predictive error of plus 4% for tankers, minus 3% for bulkers, but the standard deviations are very large. So what that's saying is that the good news is that EEXI is in aggregate, good predictor of actual CO2 emissions. The model is well calibrated for accuracy across the fleet, but there is high variation, and I suspect that is because it's difficult to capture and model all of the idiosyncrasies of the vessels that are out there. In particular, if you were an owner of a vessel that was sitting in one of the off-diagonal regions, so if you were at the top left of this chart, that suggests that you have a low technical index but high actual emissions. That means you could be passing EEXI but failing CII. One way of putting that is saying that either your vessel is worse than the EEXI model is suggesting, or you had particularly inefficient operations. If you're in the bottom right of this chart, you're passing CII but failing EEXI, which could mean that your vessel is actually cleaner than is modeled by the EEXI formula, or that you had particularly efficient operations in that year. And on the question of operations, we now look at the final question of my talk, which is what sort of operational CO2 savings might be possible. And this is a very cool little study that we did where we are estimating CO2 emissions from satellite data. So here we show a recent voyage of an LR2 tanker from Seyhan to Saroch, and each little dot on this picture is a satellite report, so location and time of the vessel. And we can estimate from these satellite data the CO2 that the vessel is emitting. So we have the location data, which gives us distances and times. We convert those into speeds. We then use the speed plus the data that we have about the engine on board the vessel to estimate power and therefore fuel consumption, and that then gives us the CO2 that was emitted on that voyage, or an estimate of it. Now we can then run a hypothetical simulation of this voyage. Actual journeys occur at variable speeds, and actually you can see quite high variability in speed on a real journey. The question I wanted to ask was how much CO2 would be emitted for the same journey, in other words, same distance, same duration, same cargo, if the vessel had traveled at the equivalent constant speed. So put another way, without changing trade at all, how much CO2 can we save through one simple operational change, which is going at a stable speed? So we ran this, and we looked at the, this was for the whole of the LR2 fleet. I think that was 333 vessels between 2018 and 2020, and we looked at the percentage of the CO2 emissions that were saved under the hypothetical that the vessel had traveled at constant speed compared to what it had actually traveled at. And what we see here is the distribution of those CO2 savings, which are sort of distributed around the 4% level. So the total CO2 saved was almost 1 million tons, and that was 3.8% of the total estimated emissions. And I think the point I want to make here is that there is scope. This is without changing trade, this is without addressing port congestion, idle time, it's without changing, without fleet optimization. This is simply doing all of the work that we did in those years and just doing it at constant speed, and you get almost 4% saving. So there is scope for saving CO2 through operations. Final thoughts. I think undoubtedly greenhouse gas reductions are going to be driven by technological and operational changes, I suspect mostly technological, over the coming decades. I think what I wanted to present here was that data and analytics can help the industry monitor and prioritize where it spends its resources on tackling this problem. And finally, I think it's important to not be over-reliant on metrics. There's a phrase I once heard, measure what you value because you will value what you measure. If we want to reduce emissions, it's fine to look at efficiency ratios, but we have also got to consider that they don't measure emissions directly. And if we want to measure emissions, we have to look at the whole piece. So that concludes my talk. If you want to know more about what I've just presented or any of the other products that we have, please visit our stand in the foyer. And I hope you enjoy the rest of the afternoon. Thank you very much.